Hey, what's up, everybody? So, College Board just released their sample questions for the newly modified at-home AP Calculus exams. So, I want to take some time and walk you through these questions step by step so you can do your best when you take the real exam. So, here in question 2, we're asked to justify why there must be at least one time t between the intervals 0.3 and 2.8 at which v prime of t, the acceleration of the particle, equals 0 meters per hour per hour. So whenever I'm asked to justify something, I think of one of three theorems that I can use on this test. We can use IVT, which is the intermediate value theorem. We can use MVT, which is the mean value theorem. Or we can use Rolle's theorem, which is actually just a more specific version of the mean value theorem when f of b minus f of a is equal to 0. So since we're asked for the derivative of v, our function, then we know we can't use the intermediate value theorem, so we must use MVT. So let's check to see that we've satisfied the conditions for MVT. Number one, our function must be both continuous and differentiable. So if we're looking at the opening of the question, it says that the velocity of the particle p is given by the differentiable function v of p. Well, you need to know that if a function is differentiable, then by definition, it is also continuous. So we've checked off that category. Let's also check what our difference between our f of b and our f of a is. So they give us these as our boundaries, so we can call 0.3 our a and 2.8 our b, so this is our a and this is our b. Therefore, this would be our f of a and this would be our f of b. So then f of b minus f of a is equal to 0. So we've also satisfied that condition for Rolle's theorem. So then if I wanted to answer the question, I'd probably say something like this. Because Vp of t is both continuous and differentiable, and because Vp of 2.8 minus Vp of 0.3 is 0, mean value theorem, or you can say Rolle's theorem, states that there must be at least one value of t on the interval, this interval, such that Vp prime of t is equal to 0. And that should be enough to get you to answer question 2, part A. So in part B, we're asked to use a trapezoidal sum with these three subintervals to approximate this integral, which is also known as the area under the curve. So when we're thinking about trapezoidal sum, we should think about the area that you should have learned in geometry. And the area of a trapezoid is 1/2 b1 plus b2 times the height. Or I like to think of it as we're taking the average of the two bases times the height. Well, where the heck are we getting these average of these bases, and where the heck are we getting these heights? So let me just plot these random points to give you an idea of what's going on here. So let's call this point A, let's call this point B, and if we know the x point is A, then we can call the y point f of A, and we can call the y point of B f of B. And then I'm going to do my best to draw a trapezoid. And now, if you look and turn your head sideways, you can actually kind of see that this is the height of the trapezoid. And then this would be the first base, and this would be the second base. Well, how do we calculate the height of this trapezoid then? Well, it would just be the difference between B and A. That would give you the length of the height. And then if we look at this base 1, this base 1 is exactly the same as f of a. They should have the same value. And then same thing with base 2. We can say that's equal to f of b. So then if we want to use the calculus notation, we can say that the area of the trapezoid, given x values of a and b, is we can call that 1/2 f of a plus f of b times b minus a. Well, where are our x values? Well, they're given to us. So then our first difference between our x values is 0.3. And what are the heights that correspond to it? Well, this is my f of a and this is my f of b. So then I can calculate the first trapezoid. We'll say the area of the first trapezoid is 1/2. My f of a is 0. my f of b is 5, and then the difference between my x values is 0.3. And then I can add the second trapezoid. Well, I'm going to use these for my second trapezoid. The difference between the x values is 1.4. Whoops. Let me fix that. 1.4. And then now these are my two new heights. So then I'm going to plus a 1/2. Now my f of a is 55. My f of b is negative 29. And then the difference between the x values is 1.4. And then I'm going to do one more. These have a difference of 1.3. And then this would be my f of 1 and my f of 2. Sorry, my f of a and my f of b. So we'll do negative 29 plus 55. And then that's 1.3. And thankfully I have a calculator because I don't want to calculate these by hand at all. If you add them all up, you should get that they add up to 40.75. And if you want to be careful, we're doing the area under the curve of velocity. Area under the curve of velocity is distance, so my units should be meters. So in this question, we're given a continuous function that's defined on the interval -6 to 5. And it says the figure above shows a portion of the graph that consists of two line segments and a quarter circle centered at the point 5, 3. And they give us this other point on the graph. And then we're told that if the area from -6 to 5 of f of x dx is equal to 7, find the area from -6 to -2 of the graph, and to show the work that leads to your answer. Notice that they only give us the graph from -2 to 5, and they want us to find the area of the piece off the graph. So what we're going to do first is we're going to calculate this area by splitting it up into little shapes. So this little triangle right here, right, it has a base of 1 and a height of 1, so that's an area of 1/2. From here to here, we have a triangle that's underneath the x-axis, and it has a base of 1.5 and a height of 1. So that's going to be -3/4. Okay, 1.5 times 1 is 3/2, divided by 2 is 3/4. We have this triangle over here that has a base of 1.5 and a height of 3. So that area is going to be positive 9/4. Okay, so that's 1.5 times 3, which is 9/2, divided by 2 is 9/4. And then this area right here, this area is actually the hardest part to calculate. So what we have here is we have a square, right? This square has dimensions 3 by 3, and then we want to minus out this quarter circle. So the area of that shaded region is going to be 9 for the square minus 9 pi, which would be the area of the whole circle, right? Pi r squared, right? These are my radii, 3 and 3. But then we divide it by 4 for the quarter circle. So if we add up all these things, we can write that the integral from -2 to 5 of f of x dx is just equal to all of these things added up. Well, a half minus 3/4 is a -quarter. -quarter plus 9/4 is actually equal to 2. 2 plus 9 minus 9 pi over 4, the whole thing should add up to an area of 11 minus 9 pi over 4. Okay, so that's the first step in the equation. The next part is we need to use some integral rules. When we have the integral from -6 to 5 of f of x dx, we can split it up into two separate integrals, right? We can call it the area from -6 to -2, and then we can also add the area from -2 to 5. Right? It's as if we just split up our area into bounds, and as long as these numbers match, you can split up any integral that way. Okay, so we can do some substitution then, right? We know that the left-hand side should equal 7 because that's what the question gives us. We're looking for this part, so we can just rewrite that. And then from earlier, we know that the integral from -2 to 5 is 11 minus 9 pi over 4. And then when you rewrite the equation, you should get that the whole area is equal to negative 4 plus 9 pi over 4. And that's your answer for part A. Now, if I were to reward points for this question, I think I'd probably give a point for you being able to calculate the area under the curve, this 9 minus 9 pi over 4. I think I'd also give a point for you knowing that the area can be written as the sum of two subintervals, so I'd probably give a point for that. And then for the third and final point, I'd give a point for the correct answer here. In part B, we're asked to evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. So let's see what we can do with this. Well, one of the properties of integrals is when you have a sum of integrals, you can split it up. When you have a sum inside your integral, you can split it up, right? So it's 2f prime of x dx plus the integral from 3 to 5 of 4 dx. So that'd probably be my first step. Whenever you have a constant, you can also pull out a constant in front of your integrand. So we want to evaluate the integral from f prime of x dx. Well, what's the integral of f prime of x dx? The integral of f prime of x is just f of x, right? So it's 2. And then we're going to evaluate f of x from the lower bound of 3 to the upper bound of 5. And for this one, I'll just repeat this over here just to make sure I'm consistent with my work. The integral of 4, though, is just 4x, right? So then we just need to evaluate 4x for the lower bound of 3 and the upper bound of 5. And then we can just go ahead and do some plugging in, right? So we just need to evaluate what f of 5 is, and then we need to minus what f of 3 is. And then for the second half, we just need to do 5 minus 3. Luckily, we have the graph of f here, right? So f of 5, well, that's just 0, right? And then f of 3 is right here, but they give it to us in the question, right? They tell us that the point is 3 minus rad 5. And so you can just write out 2, parentheses 0, minus, make sure you put this quantity in parentheses, otherwise you might forget to distribute that negative. And then 4 times 5 minus 3 is just 8. And if you don't want to simplify anymore, you can just leave it like this. Otherwise, I can let you go ahead and simplify. But remember, as long as your number is numerically equivalent, it doesn't matter what numbers you use. So you do not need a perfectly simple answer. Now, if I were to reward points for this question, I'd probably give this question 2 points. I think I'd give 1 question for taking the proper antiderivative, getting this f of x and getting this 4x, and then I'd probably award another point for the correct numerical answer. So here we have part C. It says the function g is given by g of x is equal to the integral from negative 2 to x of f of t dt. Find the absolute maximum value of g on the interval negative 2 to 5 and to justify your answer. So whenever I see something like this, I think of the fundamental theorem of calculus part 2. Part 2, for those of you who don't speak French. If g of x is equal to the integral, then we can just write out that g prime of x is equal to f of x. Okay. I normally do this because I've seen on scoring guidelines that they'll just give you a point for writing that out if you recognize the fundamental theorem of calculus. So then what do we do? If we're trying to find the absolute maximum, we need to consider our critical values. Critical values are when g prime of x is either equal to 0 or undefined. Well, g prime of x is just our f of x, right? And this is our graph over here. Where is our graph equal to 0? Our graph is equal to 0 at negative 1. This is positive 1/2. And then we have 5, right? So we can list out our critical values as x is equal to negative 1, positive 1/2, and positive 5. So they'd probably give you another point there for looking at the critical values. And now, when you're looking for the absolute maximum, I think the easiest way to do absolute maximum is to do a t-chart. So one of the ways that AP Calculus has said that they can award you points is by you plugging in the critical values as well as your endpoints into the function to assess which values are either the greatest or the smallest depending on what you're trying to find. So we need to plug in -2, we need to plug in -1, we need to plug in 1/2, and then we need to plug in the number 5. Well, when we plug in the number 2 into g of x, we're just evaluating the area from -2 to -2, right? So that area is just 0. Now what's going to happen? If we're going to evaluate g of -1, that's saying we want to find the area from -2 to 1. We've done that over here, right? We did that for part A. So this answer is just 0.5. And now we need to do the total accumulated area from -2 to 1/2. So that's positive 0.5. This is a negative 0.75. So we have a net negative. And then we have g of 5. I think we did g of 5 in part A, right? So if we add everything up, we should get your final answer is 11 minus 9 pi over 4. And you can use your calculator to verify, but out of these 4 values, the maximum value is this one down here. So then, how would you answer this? You should say something along the lines of g of x reaches a max value of 11 minus 9 pi over 4 when x is equal to 5. So now where would they give you the points? I think they might give you a point over here for doing the fundamental theorem of calculus. I think they'd give you a point for getting your critical values. And then I think they'd give you a point for somehow justifying that this is true, right? So in this case, the t-chart and this sentence is an appropriate amount of justification for this type of question. So that's 3 points. 1, 2, and then here's your third point. Part D is a limit question, and it wants us to find the limit of 10 to the x minus 3f prime of x over blah, 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 blah. So many symbols, right? So whenever I do a limit question, I always start out by rewriting the limit notation. They want to make sure that students are very specific with limit notation because the limit doesn't necessarily equal the value of the function. So I'm going to rewrite the question here. Now, after I rewrite the question, then I could go ahead and do a direct substitution to see what I get. 10 to the first minus 3 f prime of 1 all over f of 1 minus arctan of 1. So what is f prime of 1? Well, f prime of 1 is the slope of the graph at 1. Well, the slope of the graph, if I just go here and just do some counting, I get up 2 over 1, right? So then I can do this equal sign. As long as this equal sign lines up with the one above, then I don't have to rewrite that whole thing. Wouldn't that be awful if you had to rewrite it every single time? So then I can substitute 2 in for f prime of 1. And then what is f of 1? The value at 1 is just 1. And then hopefully you remember that arctan of 1 is pi over 4, not 45 degrees. Remember that all your trig functions should be answered in radians. But of course, since they're not grading you on the numerical value or your ability to do inverse trig, you could leave it as arctan of 1, honestly. And then at that point, you don't need to simplify any further. But just in case there are those of you who are sticklers for the simplest function possible, we can say that's 4 on top, right? And on the bottom, if we do a common denominator, it's 4 minus pi over 4. And then finally, we can multiply by the reciprocal, so we get 16 over 4 minus pi. We didn't have to do L'Hopital's rule on this one. Now, how would I award points for this question? I'd probably award a point here for getting that the slope of the function is equal to 2. And then I'd probably give a point for the final answer, making sure it's the exact numerical answer. And then I probably would make it a max value of 1 if you didn't repeat this limit notation and if you just started plugging things in. I think AP Calculus can be that nitpicky sometimes. Finally, we get to part G, the 7th part of a 25-minute question. And it says, suppose that g of x is equal to the integral from -2 to x of f of t dt. is the rate of change of g increasing or decreasing at t equals 1. So the first thing I do is when I see this, I'm automatically going to evoke the fundamental theorem of calculus, which says that if you have g equal to the integral of f, then g prime of x is just going to equal f of x. Now, the natural instinct here is to be like, okay, well, rate of change is just g prime of x, right? And then the rate of change, well, I'm looking for increasing, so I want g prime of x is equal to 0, right? However, do not do that. G prime of x greater than 0 means that g is increasing. Now, what do we want, though? We want the rate of change increasing. So we want to find when is g prime of x increasing? Well, g prime of x increases when g double prime of x is greater than 0. They're not going to give you a question that easy, right? Find the derivative and plug in. So if we know that g prime of x is equal to f of x, then we can also say that g double prime of x is equal to the derivative of f. So let's just go ahead and plug in values in. So then g prime of 1 is equal to f prime of 1. We look at the graph, right? So here's the point. And then f prime of 1 means we need to calculate the slope. It's nice and simple. Up 2 over 1. So then f prime of 1 is equal to 2. And we can just go ahead and answer our question now. Because g double prime of 1 is greater than 0, then the rate of change of g is increasing when t is equal to 1. So this is definitely a tricky question where you have to pay attention to the wording. So how would I award points here? I think I'd award points here for getting the fundamental theorem of calculus. I think I'd get another point here for you calculating the rate of the rate, right? So figuring out that the slope is 2. And then I'd give finally 1 point for the correct explanation right there. Alright, that's it for this video. If you have any questions about any of the problems, feel free to leave a comment below. Otherwise, if you found this video helpful, like this video or subscribe to our channel.